Okay, functions Friday. Uh, this is the second part of the notes from yesterday. That's on the same. It's on the same note sheet. There's 2 pages. Did the first page yesterday. Doing the second page here today. Today is 3/20/20. Oops. And yesterday we talked about arc length. Okay, so arc length I compared to the crust of a pizza. We were measuring the crust of a pizza. What's that? The outer edge of that circle. How big is that? What's its measurement? What's its length? Okay. Today we're going to find the area of an entire pizza slice. Okay. So this is called a sector, the entire area of the whole pizza crust and the slices. Okay. So the area of a sector, the area A of a sector, of a circle, with a radius r and a central angle of theta is given by the following formula. Okay, so again, let's look at the players here. We got the radius, which extends from the center to the edge of the circle. And you have the central angle, theta, okay, which from standard position goes from the x-axis to the wherever it ends. Okay. And we're trying to find the area between the radius, the two radii, and the pizza crust, which yesterday we measured as S for arc length. All right, so we're trying to find this grayed area. Okay. It's given by the following formula. Area equals 1/2 times theta times the angle times the radius squared. Okay. Where again, just like yesterday, this formula only works if theta is measured in radians. Okay. Now this formula should look somewhat similar. If you know the area of a circle is area times pi r squared. Okay, that's the area of an entire circle. Well, remember, the entire circle is 2 pi radians. So if you do 2 pi radians times 1/2, you're just left with pi and then r squared. Okay. So it's same formula, just written a little differently. All right, and just like yesterday as well, if your angle measure is not in degrees, you have two options. You can convert it right away and then use the original formula, or you could just add that times pi over 180, the same thing we did yesterday. Just add pi over 180 to the end of that formula, and it'll automatically convert it for you. Okay, because it's all multiplication. It doesn't matter where you throw that in. Okay. So if your angle is in degrees, you're going to use a different formula, the exact same thing, 1/2 times theta times the radius squared, and you're just going to add times pi over 180 at the end. All right, so we'll do 2 of each, 2 radians, 2 degrees, and then a word problem. Oh, never mind. We're only going to do 1 of each. Really cut this down. All right, this first one, find the area of the sector. It gives you a radius 4 centimeters. It gives you a degree measurement of the angle, 74 degrees. Okay. We need to find the area. All right, now again, this one's in degrees, so we're going to have to use the formula from above. Okay. So we're going to take 1/2 times theta, 74, times the radius, 4, squared, and then times pi over 180. I'm actually going to put the square inside the parentheses. It doesn't matter, but I don't want anyone to be confused. And then again, this is a calculator problem. You could throw this entire thing into the calculator. You could do it exactly as you see it. Because again, if it's all multiplication, division, it doesn't matter the order. Okay. So toss that whole thing into the calculator, and you should get an area of 10.3 centimeters, and since it's an area, it's centimeters squared. Now again, Sometimes it'll say to leave pi in it. Normally I don't like leaving pi in the equation because if you leave pi in the equation, it doesn't make any sense anymore. We could, you might have a rough estimate of what 10 centimeters is like. You don't know what 3 pi centimeters is. So go ahead and just, when you do it in the calculator, either use the pi button or use 3.14. All right, second one's in radians. How do we know it's in radians? Well, there's a pi in there. Usually all radian measures have pi. There's also no degree symbol. Radians are unitless, so there's no labeling. Okay. All right, this one's in degrees, so we could go ahead and use the original formula, the 1/2 theta r squared. So 1/2 times the angle, 2 pi over 3, times the radius, 7 kilometers squared. Once again, punch that all into the calculator. Use 3.14 for pi, or use the pi symbol, and you should get 51.3. Now again, you guys should check this. Make sure you could get it from the calculator, because it's one thing to be able to set it up, but it's another thing to actually be able to use a calculator to find the right answer. All right, then just like yesterday, we have a word problem. This one's kind of tricky. Windshield wiper blade to the left, I didn't put the picture in, is 32 inches long. If the wiper blade sweeps through an angle of 125 degrees, find the area swept by the blade. All right, so what this means, again, we'll draw the picture. You guys have seen a windshield wiper blade, I'm sure. All right, the picture looks like this. Your windshield wiper blade, there's always that little part that it doesn't reach. Okay, it has a little wand that comes out, and the actual wiper blade is like that. Okay, and it wipes back and forth. Okay. Now, what the problem told us is that the entire blade is 32 inches long. Okay. What's not in the problem, this is my fault for copying it wrong, was that the range of the blade is 21 inches. Okay. The angle it sweeps is 125 degrees. Okay, so that's automatically our theta. Now again, from the start of the blade to the end of the range is 32. Okay. Just the blade part is 21. Okay. So that means we need to figure out what this one is. Okay. Well, if the blade part is 21 and the whole thing is 32, just simple subtraction will tell you that the little part, the part that doesn't have the wiper blade, is 11. Okay. So for a problem like this, we actually need to find two areas. We need to find the area of the entire 32-inch section, and we're going to have to find the area of the 11-inch section. Okay. And we're going to use that we're going to subtract those two answers to find the area that's left over. Okay. So again, in kind of a different sense, if you had it's like having a circle inside of a circle. Okay. If you're trying to find this area of just kind of the outer donut, if you want to find that area, you have to find the area of the big circle minus the area of the little circle. We're going to do the same thing here, but we're not using a full circle. We have these half circles, these semicircles. All right, so let's start by finding the area of the whole wiper blade. Okay. The area of the whole wiper blade, it's always going to be 1/2. Okay, so this is the whole thing. I'll say whole wiper. So 1/2 times the radius. The radius of the whole thing is 32 inches long. Times the angle, theta, 125. It's right above it. And then since it is given in degrees, times pi over 180. Oops. All right, the second area we're going to have to find, we're going to have to find the area of the part that doesn't touch the windshield. So the non-blade. So that area is going to equal, again, everything stays the same, 1/2, except for the radius. The radius of that part is only 11. 11 times 125 times pi over 180. All right, we're going to find those two areas, and then we're going to subtract them. The area of the entire wiper apparatus is going to be 1,117 inches squared. The area of the non-wiper blade portion is 132 inches squared. So the area of just the wiper blade is going to equal the whole thing minus the non-blade. Or in this case, 1,117 minus the 132. This will give you a total area swept by the blade of 985 inches squared. Okay. All right, so that's area of a sector. Not all the word problems are going to be that difficult. But I figured I'd give you the hardest one in the notes, and then give you easier ones on the homework. All right, homework's posted already. It is going to be due by the time you get back from spring break. I would do it today so you don't have to do it over spring break. All right, that's it. Area of sector, trig part 2, done. And we'll see you in a week.